Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on August 5th, 2025, so just about 3 days ago. This paper finds that many AI systems for document understanding suffer from an overconfidence dilemma. They tend to provide an answer even without having the evidence. The paper is titled, "Are we on the right way for assessing document retrieval-augmented generation?" And this tendency to speculate is a major challenge. To address this, the authors introduce a new evaluation benchmark called double bench, revealing that the biggest bottleneck for these systems is still finding the right information in the first place. Also, the authors shared the full double bench repository on GitHub. In it, you'll find the complete benchmark dataset itself. This includes all the documents, the structured single and multi-hop questions, and the detailed annotations they use for the evaluation. Alright, so this figure really visualizes the core problem the authors are tackling. It lays out a scale for assessing query clarity. On the low end, you see existing benchmarks with really vague questions like, what is the title of the slide? These are just too ambiguous to be useful for testing. Then, at the very top, you have double bench. Its questions are very specific, for example, asking about union strikes during a specific prime minister's government. This clarity is what's needed for a truly rigorous test. Building on that idea of query clarity, this next figure from their pilot study details several critical limitations in existing benchmarks. For instance, some ask questions that are unrealistic, what the authors call out-of-distribution scenarios, by already telling the model where to look. Other benchmarks use so-called multi-hop questions that are too simple, or only evaluate one specific part of the system, like retrieval or understanding, but not both. These issues mean we aren't getting a realistic picture of system performance. This table then lays out those limitations in a really clear side-by-side comparison. You can see that most existing benchmarks only evaluate one component, either the embedding model for retrieval or the MLLM for understanding. But double bench, shown here on the bottom row, is designed to assess the entire RAG system. It also stands out by supporting 6 languages and featuring a dynamic update capability. This capability is important because it allows the benchmark to be refreshed, preventing models from simply memorizing the test data over time. Okay, so this diagram shows the full construction pipeline for double bench. It all starts on the left with pre-processing raw documents, filtering them, and splitting them by modality. Then, it branches into 2 tracks for creating questions. One generates simple, single-hop questions. The other creates complex, multi-hop queries using knowledge graphs, which are basically structured networks of facts and relationships. And finally, everything is meticulously checked and refined by human experts on the right, which guarantees the quality of the final benchmark. Alright, moving to the results. This table details the retrieval accuracy for several state-of-the-art embedding models. These models are crucial, as they convert document content into numerical representations to find relevant information. The results are broken down by query complexity, from simple single-hop to much harder 3-hop questions. You can clearly see performance drop as the reasoning gets more complex. What's really interesting is that the gap between text-only models and the visual and multimodal ones is closing, showing how advanced text-based retrieval has become. This figure then breaks down the behavior of the full RAG frameworks, and it reveals a fascinating problem the authors call the overconfidence dilemma. For example, a simpler framework like M3.RAG is more cautious. When it can't find the right information, it often correctly refuses to answer, which is what the large teal sections show. In contrast, more complex agents like MDoc agent and Vidu-RAG tend to answer almost every time, even without evidence. This behavior, shown by the red bars, leads to speculation or hallucination. So, this overconfidence problem really underscores the value of a benchmark like double bench. It shows that the biggest bottleneck is still retrieval accuracy, and that we need frameworks that know when to admit they can't find an answer. That's it